Okay, so we're going to use this four-step method to solve this first problem. It says solve the triangle for angle theta. I see theta's been labeled for us. That was nice. I see two sides, a 10 and a 6. Step 2 is label those sides. So we'll start with the 10. Is the side labeled 10 my opposite side, adjacent side, or my hypotenuse? Who knows? Got to vote for hypotenuse. Why hypotenuse? Very good. I agree. So this guy is our hypotenuse. We can tell because he's the longest. Looking at the picture, he's the longest. Also, he's across from the 90. Perfect. Yeah. The other one is the side length 6. This guy here, is that guy my opposite or my adjacent? Opposite. Opposite. Very good. Because he's opposite or across from the angle we're interested in. And just a minute ago, you guys told me if I have the opposite and the hypotenuse, I should use a sine function. So when I set up my equation, sine of my angle equals my opposite side over my hypotenuse. Yeah. Straightforward, yeah? I want to get at the theta inside of the sine function. I have to undo sine functions. We undo sine functions with their inverse buddies, sine inverse. And I do it to both sides. So if I take sine inverse of sine, those two things cancel and leave me with theta. On the other side, I get sine inverse of 6 over 10. And at this stage, unless it is a number that is on the unit circle, we're going to grab our calculator and get a decimal answer. Today, we want to find our angles in degrees, because in right triangles, our brain tends to process degree measures better than it does radians. So make sure your calculator is set in degree mode. And you pull up sine inverse by doing second sine, and I need somebody to give me the value for sine inverse of 6 over 10. You have a calculator. What's sine inverse of 6 over 10? Make sure it's in degree mode. 64.15. Did anybody else get a 64.15? And Brittany is shaking her head no. And Paul is shaking his head no. I also think no. And here is why, and here's why degrees are helpful. I recognize this triangle as a special triangle. This is equivalent to a 3, 4, 5 triangle. Because I see the 3 and the 5, they're both divisible by 2. They become 3 and 5. I know the missing leg is a 4. When we look at these two angles, the angle that is opposite the shorter side should be an angle that is smaller than 45. The angle up here that's opposite the longer side should be bigger than 45. So I think what we were just given is this angle up here. So not wrong, just the opposite of what we're looking for. So if we redo this, what do we get? And I'm going to bet it's the complement, 20-something. Paul, you were one shaking your head no. What did you get for this one? 26.36? 36.87. 36 and 60-something. Was it 60-something? Did anybody else get 36? Yeah? Okay. I'm not sure what happened there. Fascinating. We'll have to double check. And this is in degrees. That makes sense. I know it needed to be something smaller than 45 because it was opposite the shorter of the two sides. Yeah. This is going to happen most often when you have the hypotenuse in one of the other legs and you just use the opposite of what you were supposed to use. You use cosine instead of sine or sine instead of cos. You had your opposite and adjacent labels backwards. And you'll get the angle that's in the other corner of the triangle. That's a pretty common mistake. It's going to happen a lot. We're going to try another one. And I need some people to help me. Nati, what is the first thing I should do? Step 1. You're on step 2, but I'll go with it. I know where my angle is. Label the sides of the triangle relative to that angle. Good. So which two sides do we see? I'm going to call on the table behind Nati. I'll give Nati a break. Daniel. The sides with numbers, which two sides are those? Hypotenuse and adjacent. Very good. Hypotenuse is the longest. Adjacent touches the angle that we're interested in. Yeah, good. And then the next question. Alexis, based on the fact that I have adjacent and hypotenuse, which trig function? Cos. Perfect. Cosine is adjacent over hypotenuse. So cos of theta is adjacent over hypotenuse, 9 over 12. How do I undo a cosine? Liliana, how do I undo a cosine? Yes, very good. Inverse cosine. So theta is cos inverse of 9 over 12. Somebody at that back table with the giggles. What is cos inverse of 9 over 12? I saw Jennifer passing the calculator off to somebody else. Jennifer, what did you get? Gotta vote for 41.41. Did anybody else get 41.41? I see some nodding. Very good. I can see in the picture the side that's opposite the angle, the one that's not labeled, is a little bit shorter than the 9. My angle should be a little bit shorter than 45 degrees. Yeah. Good. Yay. I'm going to put 5 minutes on the clock. I want you to try the next 2 examples in your small groups. Okay, so we're going to go ahead and go through these. We're going to have 2 student volunteers. Vonnie's volunteered to do the first one. You want to come on up, Vonnie? You just use your finger, yeah. Oh, there we go. Oh, your paper bumps the board, and when it bumps the board, it does that. Thank you, Vani and Yaya. Very good. So we'll start with the bottom and work our way up. So first question, how many of us got 23.63-ish? Seeing lots of hands and nods. Very good. So we all agree on the answer. Happy face. Do we all agree on the choice of tangent as the appropriate function? Very good. We have opposite side, we have adjacent side. We know that's tan. There is one thing I want to point out that's a matter of notation and not correct incorrect. So this problem was done perfectly. You got the right answer, you used the right trig function, you set up the right picture. Tangent is a function. It takes arguments inside of it, and the same is true for tan inverse. So when we use tan inverse, you'll notice when I was writing it, I was doing what you did here. So I had tan theta, and they can call me back later, and I would do this. But you'll notice I didn't write it on both sides. I was just indicating that's what I was doing to the function. Because what's actually happening is this. I'm taking tan inverse of what was on the left, and I'm taking tan inverse of what was on the right. And those things come after the tan inverse because they're arguments inside of the tan inverse function. So it's not technically multiplying by tan inverse, it's taking tan inverse of whatever was sitting there. Just like if I wanted to do a square root, I would have to put this under the square root. I wouldn't multiply it by the square root symbol. So inverse trig functions were kind of like we treated square roots undoing squares. They had to be over the thing you were trying to take the square root of. Yeah? Right answer, just a little bit of notation. Very good. Very good. Who wants to do the next one? Yes, come on up, Melissa. Happy face, happy face.
Natalia Lopez?
Yeah? Lucky you. Homework's in Delta Math. We will see you tomorrow. Thank you, Melissa. Very good. Yay. Okay, we'll do the same process. We'll start with the answer. Do we agree with 26.23 degrees? How many other people got that? And I'm seeing some nods and some shaking the head no. What did we get different? 23.5? We agree it's 20-something. Let's see. What do you got? Let's see. Oh, look at your trig function. Look at their trig function. And that's a good question. Why are we using sine here? SOHCAHTOA, sine is what over what? Opposite over hypotenuse. And those are the two sides that were labeled. No, that's good. And I'm glad that that happened because this triangle is different than the other pictures. He's tilted on his side. This one you had to remember that hypotenuse is across from the 90-degree angle so that you can identify the hypotenuse even when the triangle is tilted. Yeah, because it's less clear in that picture. Yeah. No, good. I'm glad that happened. That was an important discussion. Good. So if we use sine, we get this. Yeah? I think there was an equal sign here that got lost. I have one more notation about notation. One more note about notation. And then I'll set you free. So we've been using theta. Greek letter, theta. This guy here. as a symbol for a missing angle. Yeah? And some of us have not written lots of Greek angles, and so we're not hip to the nitty-gritty details. This symbol here is very different mathematically than this symbol here. This symbol here with the O and this, like the diagonal slash, is used in mathematics for something very specific. It's the empty set. It is a set that has nothing in it. So when I see this on a paper, I see that. It is a set that had a condition that none of the real numbers meet. There is nothing in that set. So when we're writing variables down, if you're not comfortable with Greek letters, replace it with English letters. You can call that angle A, B, C, X, Y, Z. There's nothing wrong with that. But when you start writing down Greek letters that we have not talked about in class, you have to be aware that they probably have a meaning attached to them somewhere, and it may not mean what we want it to mean. So particularly with the Greek alphabet, be very careful about how you're writing it. I'm not going to dock you for that in this class because this isn't a Greek language class. But I want you to be aware of that because I'm assuming a lot of you are probably in STEM-related majors, and we'll see this again later. And I don't want that mistake to come up in a college class. Yeah? But good, we did the trig well. Yay. Yay. You have about 6 minutes of class time. You have homework this week in Delta Math. The first third of it is this. Please make sure your calculator is in the correct unit setting, degrees or radians, whatever Delta Math asks for. When I see you tomorrow, we're going to do the back side of the page that I just handed out today.